Hey, how you doing? This is a video for Rachie 00000. You all know her. She is the flat earther. She's pretty new to the scene, only past year or so, I think. I could be wrong with that. Um, but she has been a video she made has been addressed by conspiracy cats. So I'm making this video addressing it to Rachie concerning his video. This is part one. I've only watched the first part of his video, so I'm going to reply to this, to the first part of his video, and I will watch the rest. And um, in the next coming days, I will have the concluding part two and three or whatever. Okay, this is just 10 points I took from, without addressing his video directly, I'm just going to lay out too much. I was just going to lay out corrections for Rachie. So, Rachie, this is for you. Okay, first point. The title of, I'm going to refer to Conspiracy Cats as CC, okay, in this video. The title of CC's video is obviously not about truth and facts, but aimed at the changing of a person's mind. This has nothing to do with our natural world and whether something is or is not science or pseudoscience. The title of his video was more based about trying to change, maybe changing Rachie's mind, changing your mind, Rachie, or whatever. That has nothing to do with facts. I can try and change someone's mind, and I could tell them any amount of rubbish to change their mind, but that doesn't mean that I'm telling them facts and truth. So we are in a debate about the nature of our world. That's what's important, not changing someone's mind. People can change their own minds on their own. They don't need help from other people. Two, when CC speaks about the 9.8 meters per second squared claimed acceleration, he forgets to mention that this is actually only a calculation devised by a man named Charles Vernon Boys in the very late 1800s. Boy's calculation is based off of the pre-assumption that objects of differing sizes and weights would fall at an equal 9.8 meters per second squared in a vacuum. This is pure pseudoscience that has no real world validity, as we do not live in a vacuum, and this claim was never proven to be true anyway, even when using a vacuum chamber, as the opposite has been shown to happen. And objects don't fall at the same rate, but fall at a very fast rate due to there being no air friction. 3. CC continually refers to gravity as a force and even makes claims of this claimed force being proven by and calculated by Henry Cavendish. Actually, so just before I go on, just referring to this concerning this things dropped in a vacuum, there is absolutely no evidence whatsoever that objects of different weights will fall at the exact same rate in a vacuum. They will start to fall at the same rate in a small vacuum. It will appear that's what's happening, but they will fall very, very fast. If you slow them down, especially if the vacuum is of any size, what will happen if you slow them down? You will see, slow down the video, you will see that the more dense, heavy object hits the bottom first, especially if the vacuum chamber is of any size. With a smaller vacuum chamber, what happens is they will start falling about the same rate, and they both hit more or less look like they're hitting the bottom equally. But there was Professor Brian Cox. He was in the Sandusky, Ohio NASA vacuum chamber, and he videoed a bowling ball and a feather dropping from 100 foot up in because the chamber is just over 100 foot high, I think it is. Either 100 or 200 foot, but it's a high. It's definitely 100 foot, and they had to use camera cuts to hide the fact that the bowling ball was probably hitting the ground before the feather. So this whole 9.8 meters per second square thing, even in a vacuum, is not correct. It's just a calculation. Okay, now I'll move on. So 3. CC continually refers to gravity as a force and even makes claims of this claimed force being proven by and calculated by Henry Cavendish. Henry Cavendish never calculated what's known as Big G. This is a misconception that is rife across the internet and pseudoscience world. What Cavendish did was pre-assume that gravity as a force was a reality, and this pre-assumption was added into his apparatus setup. I have citation for this if anyone wants it. Henry Cavendish was attempting to determine an average density or weight calculation for the Earth, and within this attempt, he accounted for the possibility that gravity was a reality as a force of attraction between two masses. Cavendish wrote himself that any movement within his apparatus that may have happened could have been caused by temperature convection. His demonstration was a year-long observation and not a science experiment. So Henry Cavendish didn't do a science experiment, he did an observation, a year-long observation. And I have citation to prove what I just said there concerning him not determining G in his observation. From a reputable source, by the way. 4. CC claims that gravity is a scientific theory and a law. A colloquial theory is just an average theory. It can be anything from why does my boiler act up to how do UFOs fly, etc. Right? A scientific theory is something that has been proven through scientific experiment, through science experiment that adhere to scientific method. A law of nature is something that holds true and constant always, i.e. hot will always flow to cold, or high pressure will always flow to low pressure, etc. A natural law or law of nature is not a scientific theory. Natural laws do not get proven or disproven by science experiment. They are something that holds true always, without fail, and are unchanging. For instance, your cup of coffee will never start heating up. It will always proceed to cool down under everyday normal conditions. So any claim that gravity is both a scientific theory and a natural law is immediately debunked. 5. What is a scientific hypothesis and hypothesis test? A scientific hypothesis is a formed prediction based on the witnessing of a natural phenomena, i.e. a rainbow, a disease, diffraction, evaporation, etc. These are cause and effect questions, as when we observe an effect in the natural world, we then look for the cause to this observed effect. And this search for a cause is the reason for the creation of a scientific hypothesis. A hypothesis is your prediction for what is causing the effect that was observed, and this leads us to the hypothesis test. A hypothesis test is also known as a science experiment, and a science experiment has a particular number of steps, and the collective of these steps is what's known as scientific method. So what are these steps? A. Observe a natural phenomena. So that's the effect you will observe in nature, in the natural world, not within a man-made device. As we know the cause of that, it's man-made. It has to be something that's observed in the natural world. As I said, rainbow, disease, evaporation, diffraction, etc. B. State your independent variable, your presumed cause of the effect observed. So your independent variable will be one thing and one thing only, and you will manipulate this, and this is what you presume to be the cause of the effect you observed. C. State your dependent variable. The dependent variable, the effect you wish to see by manipulating your presumed cause. So by manipulating your independent variable, you wish to see that your dependent variable, which is the effect you observed. So your dependent variable is your natural effect, what you observed. That would be your dependent variable. So your independent variable, which would be one thing, when you manipulate that, right, that is you're hoping that causes the effect that you observed. So your dependent variable is dependent on your independent is the effect, and it's dependent on a cause. So if you find the cause with your independent variable, then the dependent variable, which is your effect, will be dependent on that. It's very simple, right? You presume something is causing something, you manipulate it, you isolate it, and you manipulate it. And if it shows to be causing it, then you've proven that that is the cause to the effect. That's how it works. D. State your control variables. Things that will be unchanging through your experiment, i.e. time, temperature, amounts, etc. So these are things that won't be changing. These are things you will keep constant, so they do not interfere with the results of your experiment. Okay, so time is always a control variable, and temperature, and then there's different, it depends on what you're doing. It could be amounts of things you want to keep control, things like that. So you'll always keep those things controlled, okay, during your experiment. E. State your null hypothesis. This will be the opposite from your presumed cause. So if your presumed cause states that X is the cause, then this is your positive hypothesis. Your null hypothesis would state that X is not the cause. So either way, you will prove that X is or is not the cause to the effect you observed. So when you use scientific method, your independent variable will either be, which is your hypothesis, what you claim to be the cause of the effect, that will be proven to be correct or not correct. So you will find out at the end of that experiment whether what you presumed to be the cause is definitely the cause or is definitely not the cause. So you by proxy always prove something. You always prove whether something is or is not the cause. This is the point of scientific method. So there is no grey areas, there is no maybes. It is a definite. You get to the bottom of whether what you presume is the cause is or is not the cause. So there's no messing around. And after that, you can take that forward with you as a definite, something that you know for definite, that this is certain thing is the cause or is not the cause of that effect. F is do your experiment, and G is publish hypothesis and results for replication. So when you've done your experiment, you then publish your hypothesis and results for other people to replicate. And just so they know through replication that what you've done is true and it holds true always. Okay, that's scientific method. So 6, does gravity have the backing of a hypothesis and hypothesis test? Question, no is the answer. There is no hypothesis and hypothesis test for gravity, as neither Isaac Newton, Henry Cavendish, Charles Vernon Boys, or Albert Einstein put forward such requirements for gravity to be considered a scientific theory, making gravity and all claims of it colloquial theories at best. Henry Cavendish did not perform an experiment but an observation, and the proving of gravity was not part of it. 7. Is gravity a force? No. Gravity stopped being described as a force of attraction between masses in 1915, when Albert Einstein's colloquial theory of general relativity was widely accepted by mainstream science as the current most accurate description of and for gravity. Einstein stated that the uneven distribution of mass caused the effect of the curvature of spacetime. Now, Einstein never defined exactly what he meant by the words mass and effect. So, since World War I, gravity has not been a force of attraction between masses, but an undefined effect. Einstein's field equations, of which there are 10, do not account for more than one mass, so all claims of a force of attraction between masses are false claims, as they are not in line with the current beliefs of mainstream science. So any and all claims that the Cavendish observation shows a gravitational force of attraction between masses is false. 8. Has gravity ever been isolated or proven? No is the answer. Gravity comes from the Latin word gravitas, meaning weight, and weight and mass are claimed to be different things, but only within a mass attracting mass paradigm, as my mass will stay equal in the heliocentric model's belief, but my weight can change depending on the strength of gravitational attraction between my mass and the mass of the Earth or Moon, etc. in that heliocentric belief. But gravity is not a force between masses, but the effect of the curvature of space-time, whatever that nonsense is. So technically weight and mass are equal at all times regardless of their placements, in accordance with Einstein's theory of general relativity, as his field equations account for no more than one mass at a time. So weight will not and cannot change in that paradigm, which causes problems for the supposed moon landings. 9. Is it possible to prove a force of gravity with scientific method? Let's see. So our observed phenomena is apple falls. Our hypothesis is that this natural effect is caused by a natural force. So what is this force and how can we manipulate and isolate it to prove that it's our cause to our observed effect? Our independent variable will be our presumed cause, but you have to be able to manipulate your independent variable. How do we manipulate a force we presume is the cause to our effect if we can't find this force? So technically we cannot prove that there is a force attracting the apple to the ground with scientific method, but we can show that the apple's density is greater than the density of the surrounding air, so there is insufficient structural support and pressure resistance to contain the apple from falling as it is denser than the surrounding medium. 10. Can we reify a force of gravity into our presumed reality? Yes, we can pretend that there is a force of gravity that is a constant in our world and that this force is an attraction between masses. If we beg the question enough and use incorrect logic as proof, while also denying Albert Einstein's colloquial theory of general relativity, we can do that. So, if we state that a force is always there and is always affecting all things at all times, attracting masses to one another, then this makes the belief easier to believe. If I, for example, state that a tennis ball will fall toward the ground due to a force of attraction between masses, without ever proving the existence of said force, then I can keep believing it. I can also use incorrect logic in the form of what's known as incorrect modus ponens. Correct modus ponens states that if A is true, then B is also true. A is true, so B is true. Incorrect modus ponens states that if A is true, then B is also true. B is true, so A is true. That's incorrect. Correct versus incorrect modus ponens is done with an intellectual sleight of hand, as incorrect modus ponens is confirmation bias that backs up a belief and is not a logical proof of a cause to an effect. Incorrect modus ponens is backward logic, as if there is a force of attraction between masses, then when I drop a tennis ball, it will fall to the ground. When I drop a tennis ball, it falls to the ground, so there is a force of attraction between masses. No, this is faulty logic, as the presumed cause of the tennis ball falling has not been proven, as only the effect is shown. The example above is a classic example of faulty logic, as the tennis ball falling is only the effect, but the person is using the observed effect to create and conjure a fantastical force into existence, with the only proof of this claimed force is the effect that is claimed to be caused by this force, that has not been proven to exist yet. But for the person searching for confirmation bias of the existence of this force, the effect of the tennis ball falling is all they need. Okay, that's the end of part 1. Thank you.